I'm pleased to welcome Dario, co-founder and CEO of Anthropic. I really see us a little bit as birds of a feather. We have common background in doing PhDs in physics, but then turning to entrepreneurship to tackle the domain, hopefully in a disruptive way, but to do so in a way trying to have the biggest positive impact and reduce harms. And you're obviously focused on AI, and I'm focused on space, but similar attitude. And I'm particularly pleased that we're here today because we're announcing our partnership together, which we'll get into here shortly. Welcome, Dario.
Yes, thank you for having me, and excited for the partnership.
So I want to start a little bit with AI applications. So everyone's talking about AGI, it's the rage, obviously, but what are the biggest challenges you see in the world that AI can meaningfully advance, and what's Anthropic's strategy to advance them?
Yeah, I see a number of things like AI as a general purpose technology.
Mm-hmm.
Things ranging from biology, which I'm particularly excited about because
Yeah.
used to be a biophysicist. I'm quite excited about the potential for things like healthcare, advancing science, and in our collaboration with you, the ability to understand the earth better for the sake of many cases that will have a number of scientific applications as well as improving the state of our planet and improving our ability to manage it. I think some of the challenges come, the key development of the models itself, of course, is its own science.
Yeah.
It takes a lot of work. But then when you actually want to apply the model, creating the adapter between the fundamental model and the downstream application often requires companies to work together, right? It often requires partnerships with companies. We're trying to serve every industry with this general purpose technology. And so when we partner with a company that understands some part of the world much better than we do, I think the important thing is to kind of work together to do something that we couldn't have done alone, because we understand AI, but we don't necessarily understand all the implications of all our models or all the things it's good at or can be used at. So, I think at a high level, that's one of the biggest challenges.
Talk a little bit about what's rate limiting the development of AI in general today. There's compute, there's talent, there's data, there's algorithms. Where's the bottleneck?
Data is a really interesting one. In terms of general data, there's a lot of it around, and we've been able to basically scrape the entire internet, and there are some techniques like these new class of reasoning models that rely less on data. Where I think data is really important and valuable is the thing that I said before, which is when you're trying to do a task in some particular domain,
Mm-hmm.
getting the best performance out of that domain. Data is going to be particularly important. There are some things that you just don't learn by reading the internet, right? And I think the partnership we're doing together is maybe a prime example of that, where Claude, our model, has been trained to analyze all kinds of images by looking at images on the internet. But the fraction of those images that are satellite data, that are geospatial data, is tiny. While you guys have an enormous amount of such data, it's the general model that we've trained. It's going to help. We're going to start from a much more advanced place. The models can already do great things out of the box, but there is a much greater than that potential for the models to become better at this task that is somewhat similar but somewhat different from normal image analysis. I think there's a lot of value in this specialized data to make these fine-tuned models for particular applications.
Yeah, 100%. And so let's move to space a little bit and those Earth applications in particular. So, it's interesting. There is a revolution going on in space. People all know about the lower cost rockets, the increasing fleets of satellites, and most of that. We've actually seen a 1,000-fold increase in cost performance of satellites over the last 5 or 10 years. So it's a bit like the mainframe computer to desktop computer sort of equivalent, and of course unleashing lots of applications. But the big upshot of it is new data sets about the Earth or new communication data around the Earth. One way or another, it's about data. We alone at Planet produce 4 million of these 47 megapixel images to scan the whole Earth every day. It's a lot of data. I think of how LLMs, as you say, have figured out how to semantically interface with the web, the data on the web. analogously, you can imagine a semantic interface with all of these images. I call that sort of vision queryable Earth or searchable Earth. What vision excites you at that interplay between AI and space? That's one. Is there others that come to your mind?
Yeah, I mean, well, I think that one is pretty exciting, and I can put it into context a bit more, right? So, in the space of text, there's been a lot of stuff that's been done in this kind of queryable or summarize or search, right? There are whole companies, most of whom are our customers, who have their whole business model around how can I find, summarize, search, sort through data better than I could before, better than base search engines can do it. But all of that has been text, and as you point out, in principle, the same thing can be done just as well with images. But if I think about in the internet context, well, of course you want to do internet search. It does come up, but actually, I think it wasn't until it wasn't until a use case like this, right? Satellite data in space, where it's really like you're kind of doing the same sort of queryable thing for images. That has been a core part of our business model for text for so long. I'm sure we'll have more advanced types of things. I'm sure we'll be able to analyze video. I'm sure we'll be able, there's much more value to be produced here. But this idea of searching through a large number of images for a particular thing, it feels like I'm not the expert on space and satellites, but it feels like this use case is perfectly made for that ability of AI.
Absolutely, and scanning for large areas for changes that you might be interested in, sustainability or climate related, or damage assessment after a storm, or they should be able to give a quick quantification of things, quick analysis of things, and we've already seen some interesting results there. Another area is predictive analytics. So one of the things again, intuitively, one thinks about how LLMs have extrapolated the next token. Here we are with 2,500 images for every point of the Earth's landmass. Perhaps it can guess the next token, i.e. the next image, which in this case could be, where's the next flood? Where's the next deforestation? Where's the next refugee camp? Do you see that as a potential? I mean, where does predictive analytics go?
Yeah. I mean, I think that's that's pretty valuable as well. I mean, you can already ask the models out of the box today. Like, show them a bunch of images and ask them what they think is going to happen next, right? They don't even need to generate another image in many cases. Like they can just describe in words where they think things are going and what they think will happen next. So I think there's really a huge there's a huge opportunity for that. And it has analogies to what we're doing in other fields, right? If I'm any scientific application tends to involve prediction. I'm very excited about the use of LLMs for science, and so that predictive activity is basically the same one. I'm excited about LLMs for medical use cases, right? And a lot of medicine is about diagnostics, prognostics are about prediction. I think LLMs will find wide use in finance. That's definitely about prediction. If you can predict things more accurately, you can be very successful in the world of finance. So there's a lot of precedent for this to work well. We're still in early days of trying it out, but I'm just very optimistic based on the kinds of use cases that I've seen across industries.
Okay, let's come specifically to our partnership. So we're pleased today to be announcing this partnership between Planet and Anthropic. And in particular, I mean, I've been so impressed out the gate how Claude was able to do a couple of things. One is program against our API, just make that simpler. And the second was analyze our imagery or a stack of our images over time. I mean, an example, we were looking in a forested area in the Amazon and showed it a bit of deforestation. It could really accurately describe what was going on, what are the likely causes. It could reason a little bit about what's likely to happen next, what's likely to be the consequences. And it even did some estimates of what the rate of deforestation, what's the land use change, graphed it out, and because we asked it to, and I was pretty impressed with that. as you say, it hasn't seen much satellite imagery yet. So the big aspect of our partnership to start with is just to fine tune some of the models onto planet data such that they are a little bit smarter about satellite imagery than they are before. What excites you about that partnership and where it might go next?
Well, the thing that most excited me when I saw those results was as you say, not how good they were out of the box, but what that tells you about how much better they could do when they're trained on satellite data. I would actually say the typical image data that we train Claude on is actually quite different from satellite data. Satellite data is actually pretty far out of distribution of the kind of training that we do. Probably the average image is like a cat photo on the internet, right? And so that actually means there is great potential for the partnership, totally. Right? Because if it's far out of distribution and the thing does well out of the box, and you see that there's a large gain on top of that to be made, that made me think that the whole thing was just very promising. So I'm extremely excited about the magnitude of the gains.
That's interesting.
that we can get in this area.
And of course, fine-tuning a model is only the first step, because ultimately you could imagine a large model that's purpose-built for satellite data that actually ingest that into its corpus of understanding.
Or fine-tuning exists on a spectrum. So fine-tuning on a number of images that is comparable to the number of original images that we train the data on. And having worked in AI for a long time, again, when you have a general system that does pretty well out of the box, and you have a massive source of data on a somewhat different distribution, on a somewhat different task that has a lot of structure to it, the odds of getting something very good on this are quite high.
That's an interesting piece of intuition. So a couple of final questions. One is, we're both public benefit corporations. Why did you establish Anthropic as?
Yeah, as we thought about the impact of AI, I've been in the AI field for over 10 years now. I guess I should say 11 years, since it just became 2025. But I think from the beginning, the instant that we, the other co-founders of the company, understood the potential of the technology to change society, mainly in positive ways, but there are also potential negative ways, potential risks. I think it was very important to us to make sure that we prioritize some of the responsibility aspects of the field and our development of the technology. And that's evident in we built this thing called a responsible scaling plan that tells how we manage every phase of development, every phase of development of the technology. And we take it very seriously. The RSP is something that's enforced across the company. It's seen as a product requirement. And I think the fact that we can always say to investors, to anyone who's involved with Anthropic, this is the way we work, right? Just declaring yourself a public benefit company, that in and of itself, and in terms of how it changes things legally, I don't think that's enough. It's more that it's a signal of your intention of how to behave, how you think about the importance of the field and the responsibility you have, and it seems to me that you folks have the same attitude towards that.
Totally, and it does change the fiduciary duty of the directors. So
yes,
it's something real there. So just to touch on one issue there, at the interplay between AI and where we care about, which is climate and the environment, of course. There's massive benefits potentially of AI to climate and the environment, like increasing efficiency of data centers, weather prediction, even helping fusion, things like that. You can really see how it can make. On the other hand, it's funny, typically efficiency gains are not used by that to actually reduce usage. And we're of course already hitting the planetary boundaries. So AI is in general an accelerant, and it is likely therefore to be accelerant of material use as well, not just information. And so there's a challenge that it might accelerate us blowing through these planetary boundaries. How do you see navigating that? It's a classic area of the technology is amazing, but it also can drive us to throw things up fast.
The way I think about this is the way I think about responsibility for AI in general, which is that I think a lot will ride on AI has all these general capabilities, right? What that means is it can be used for good or it can be used for ill. In the cyber domain, for example, it can be used to attack or it can be used to strengthen our defenses. The same is true in the biological world. The same is true in a lot of different applications. So the order in which we apply things, I think will be very important. And the version of this for the environment and climate change is again, AI can be used to do better climate modeling. AI can be used to develop new...
And that's our choice as entrepreneurs, where we focus.
It's basically all of these applications will happen, but it's our choice which ones to prioritize and make them happen first. And so I think what you're pointing to, maybe a way to interpret it, is it's an opportunity and a warning. That if we do things in the wrong way, then in various areas, and climate is one of them, it could make things worse. But if we do things in the right way, in the right order, then it could definitely make things a lot better. And I think that's yet another reason why we, and I would expect you, have built this public benefit structure, that we have the liberty to make these choices.
Totally. I want to end on a futuristic note. I see actually this next decade that we might have a confluence of three meaningful, maybe even Copernican moments. One is, of course, AGI, but another is that there's a very good probability of us discovering life off Earth. And another is potentially decoding the speak between certain species like whales or chimpanzees and things, with the help of AI, by the way. All three happening, each are a sort of a decentering moment, getting humans to think away from this anthropocentrism and so on. How do you see them coming together? Those other two interesting to you as well?
Yeah.
How do they play?
So the second one's pretty interesting. I actually think something AI has the potential to help a lot with. So if I think about training, when I train AI systems to predict the next word, they have almost no priors, right? Their architecture is very generic. It's not structured to understand language. You can argue, linguists argue over it, whether the human brain is kind of structured or adapted in some way to language in particular. Transformer architecture is so generic, I think we can confidently say they pretty much aren't. And yet they're able to learn human languages very well. And so if we look at the patterns of communication that animals have when they talk to each other, it's there's a lot we don't know, but I think there's enough to suggest that with at least some animals, you mentioned like whales or dolphins, there's some significant complexity to their communications with each other. And so it would be my pretty strong prediction that if we can, train AI systems on the patterns in these communications, they'll be able to make sense of them. Like AI systems, they're general pattern learners and pattern recognizers. If they can learn human languages, my guess is they can probably decode something about these animals, and perhaps this would allow us to generate synthetic signals that could let us talk to the animals.
Amazing, and potentially expand our empathy circle a little bit to value them more, and therefore take care of them.
What are the dolphins and whales saying to each other? We don't know yet, so perhaps we will. And then the second one, life on other planets. I mean, I think every science fiction fan is excited about this, including me. So I would certainly love it if this was something that we discovered. In terms of the intersection with AI, again, our ability to interpret very large amounts of data. One could imagine that as we look for this life on other planets, whether we're searching it up close or very far away. Again, there's an enormous amount of data to sort through, and we might not know exactly what we're looking for. So I can imagine a synergy with AI there as well.
Well, on that note, thanks very much, Dario, for joining us.
Yeah, thanks for having me.